Hello and a warm welcome to the AI with Arun Show. What exactly is MLOps and what is LLM Ops? Which tools and services does Microsoft Azure offer to support them? What common challenges do organizations encounter when deploying machine learning models on Azure? And how can these issues be addressed? These are the questions that we'll talk about in the session today. Because my guest today is Banibrata, who is the author of the newly released book, Hands-on ML Ops on Azure. He is a seasoned senior software engineer at Microsoft's Core AI Group in Redmond, Washington, with deep expertise in both MLOps and LLM ops. Bani also specializes in operationalizing machine learning and large language models on cloud platforms. His background includes significant contributions to software engineering, cloud automation, and AI system architecture. And for my viewers, I should add that if you want to buy the book, you can go to the website packedpub.com, and if you use the coupon code AI with Arun, you get a discount of 15% on prints and 25% on ebooks. But the validity is only till October 19th. So you really want to rush. Once again, the coupon code is AI with Arun. You'll find that in the description as well. So, Bani, a very warm welcome to the show.
Yeah, thank you, Arun. Thanks for having me.
Excellent. Bani, so let's get started. What inspired you to write this book specifically focused on Azure MLOps? Did you see any gaps in the industry or the developer knowledge that you want to address?
This is a little bit of history. I'll say it's about 7 to 8 years ago. I was lucky. So it's like be in the right place at the right moment, right? So from Microsoft, we were trying to think about MLOps totally like bottom up, because we have this SDK and CLI that was existing at that point of time. That was called V1, and we had some issues. Like the information architecture was like old, and we wanted to build it up again. And as part of that, I was owning a significant portion of a lot of MLOps feature there. I'll talk about it later, like workspace, compute, influencing, and many more. So although I was part of the development, like more developer focused, but when we shipped that, it was actually a great hit, because we figured out like our analysis was really great, and many people and many customers actually were using it. At the same time, again, like once we ship things, we get issues, right? So there are customer issues, and there are also like some use cases where probably there are some gaps, and that was a very good learning opportunity. And with those, when we were solving those problems, at that point of time, I got to understand through like the real customer pain points. And then I thought like, wow, why not get these patterns and kind of make a use case, or not only one use case but abstraction, so that that can be useful for many other people who are especially new to this. And also at the same time, since it is ops focused, like DevOps to MLOps, so ops guys love CLI, like command line interface, right? I mean, you can always, for machine learning is almost synonymous to Python. There is a little bit of learning curve with Python. So CLI is like easy go, like you just run the command, right? So that was also a sweet spot. So major focus on this book is for MLOps folks who are conversant with command line, and we have this offering which is awesome, which supports modern YAML and other markup languages. So this is like an easy thing for most of the folks to. So with that thing in mind, I thought like, why not, just have some time out and get this book out at the same time to help the people.
No, wonderful, Bunny. Looks like a great inspiration for writing a book. So, Bunny, before we get started and dive deeper, talk to our viewers about what exactly is MLOps and why is it important in the overall machine learning lifecycle. Basic definitions.
Right. So I'm purely talking from like the perspective on which I wrote this book, right? So people DevOps is kind of a more matured model now. I mean, everyone uses it, especially this is on dev focus. But the idea is similar, like developers and ops merging together. But in ML ops side, we don't have really like a developer, right? So we have like machine learning engineer, we have the data engineer, we have the data scientists. So it's not like one developer role, it's like multiple roles, right? So if we want to follow the similar kind of patterns that we did it DevOps. So DevOps is pretty much like automating most of the things with a set like a set of steps which are standardized. But that set of steps, if we want to do it as is with machine learning, it's challenging because machine learning has its own terminology, its own way of addressing things. So then what I thought of is like whatever is there for the DevOps, we can abstract those and reuse for machine learning. But at the same time, building some of the concepts like when I'm in a DevOps, my main thing is like writing. So code is everything, but in MLOps I have like I'm preparing data. So there is a data preparation step, there's a data ingestion. So this is not really code, this is more than code. And there is like a training job which is running, taking that data into account and running generating a model, and then take that model and then we deploy it so that we can use it for inferencing, right? So it's not a linear code kind of thing, but it has multiple steps. So that's why like MLOps is a specialized version, more focused version of machine learning operation.
Understood. That was a brilliant explanation, Bani. Thank you. So, Bani, let's dive deeper into Azure MLOps. So, Azure MLOps offers multiple dev tools and services, right? But in your opinion, what is it very unique about MLOps, Azure MLOps, that sets it apart from other cloud platforms?
Sure, that's a great question actually. So when I was looking into the offerings from like GCP or AWS, right? They actually have similar offering, and right now since there is a lot of competition among these tools, it's difficult to find out like a lot of gaps. So they are all similar. But when I'm talking in terms of Azure and moreover on Microsoft, right? So Microsoft has this MLOps ecosystem, which has this deep enterprise integration, because Microsoft, the main focus is like enterprise, right? So when we put that MLOps into the enterprise integration scenarios, magic happens. Like we can use like Microsoft technologies, like other technologies like Power BI, Teams, GitHub, and Azure DevOps, right? Those are all Microsoft technologies. So now with that huge ecosystem of different tools where there are millions of customers, they are happy customers. If I put that MLOps, which seamlessly works with all those tools ecosystem, it's just like, as I call, like it's a magic. So that's why it stands out really well in terms of other tool provider. But that said, we have like the Microsoft MLOps, Azure MLOps that we are offering. It has the extension points also, so we can integrate with outside like GCP or AWS ecosystems. But it natively goes well with Microsoft.
Got it. Got it. So, Bani, if you can walk our viewers through a typical end-to-end MLOps flow in Azure, right? And what are some of the best practices? You've already called out some of the best practices in the book, but for the sake of our viewers on this video, if you can call out some of the best practices that companies should follow.
So typically, when I'm talking about end-to-end MLOps pipeline in Azure, the basic tenet of DevOps is like it's automation and reproducibility, right? So I am giving same input and I should get the same output, given that I'm not changing anything. So the MLOps builds on top of that. And also, when the system is getting designed, it has to be reproducible, scalable, and efficient. So the MLOps, as I said, like DevOps concepts with specialized MLOps practices, leveraging like comprehensive ecosystem. Now, the typical end-to-end pipeline looks like we have a pipeline pipeline is a like I'll say like a collection of multiple steps, which is like an orchestration engine. It has multiple steps and which are nicely getting executed, and finally we are getting the output. So there is like one initial pipeline step can be fetch data from multiple sources, right? So once I get the data, I need to clean those up, making sure like data format is nice, there is no missing data and massaging and ETL kind of things, right? So that can be one step. Now once the data cleaning is happened, there is like feature engineering. That means which part of the data or which columns or which part of the data set is relevant for my machine learning, which is like clean, which I can use for inferencing, right? So that is like feature engineering. So once I have the feature engineering, next part is taking those features and create and feed it into a training algorithm. So when I'm running it against the training algorithm, it's trying to figure out which algorithm best suited for this particular data set and gives me what is my desired output, right? And that output is called the model. So when I take the model, I need to put it into the production. So once it goes to production, that actually sees the real life, right? Like when where real users come or they use it and get the benefit out of it. Now, if you look into these steps, like each step can be stitched into a pipeline. And pipeline is nothing but an orchestrator, which is just executing one by one. It's a like directed graph. And once the step one is completed, it goes to step two and step three, and that way. So this is like high level overview of the pipeline. So in terms of like best practices, what we always ask the practitioners to make sure things are version. Any small change into the input, because it could be cascading thing, right? If we make any small change in the input in any of the steps in the pipeline, the output will be changed. So make sure anytime we are making any small change, it has the solid versioning story. Why do we need that versioning story? To make sure like something happens tomorrow, we want to understand why it happened, we can go back saying like, okay, so it happened because we changed this small knob here. So that's where in every step of the pipeline we make sure, at least from the MLOps in Azure, the process and the framework we have, we make sure data is versioned. We make sure the features are versioned. Training model is versioned, and the inferencing side also when we are deploying, that is also versioned. So that's the promise of reproducibility. And also like the other things is like in the production when we are putting the model for deployment, we need to make sure like it is following the best practices of say it's following certain standard, right? It's not violating because it's a machine learning model. It's not a linear thing like 2 plus 2 will be always 5, right? It can be 5.5, it can be 4.75. So I'm making sure the interpretability of that out makes sense to it. So these are the like some of the founding thing that we ask everyone to follow to make sure it is more reliable, robust, and reproducible.
Right. And Bani, what are some of the challenges that companies face when they're trying to operationalize ML models on Azure? Can you talk to some of the challenges and how are you helping overcome?
Yeah, so I think there are the challenges are not like a specific type. They are like multifaceted. If again like taking a cue from the DevOps is like again like little bit simpler because as I said like there are developers only. But here I think there is a big cultural challenge, and that's where I talked about this in my book also. Is like it's a cultural shift, right? Now we have not only the developers but we have the data engineers. They are writing the ETL job and making sure data pipelines are producing the right data in right format. Then we have the data scientists. They are doing like the data visualize and data analysis, making sure like the features are solid and generating the model. And there are like ops folks also. They are taking those steps and making it reusable and putting into the pipeline so that it goes to the outside world so that people can use it in the operationalization, right? So there are different roles. So communication is definitely a key thing, and I see a lot of challenges around that. Sometimes like teams are not communicating well, and this is like a known limitation. Like if we are not talking across different disciplines and making sure we are aligned to whatever is the goal, if we are not doing that, that might bigger impact later on, because the later stage we move into the project pipeline and try to fix it, It takes more effort. So that's one thing. Then the other part, like more on the technical side, is like data management and consistency, right? So making sure, this is more like a technical and data science, or I'll say like machine learning problem, because we need to continuously monitor. As I said, like the it's a model, so that means it's a statistical model. I have some input and it is trying to understand, make sense out of that data and giving an output, right? So that means there is a statistical distribution in between. And this is hugely depend on the input data, the way I train it. So suppose I train my model today with a data distribution, which is like, say, bell curve, right? Tomorrow, so the model assumes the distribution is bell curve, and based on that, I'm outputting something, some signal. But tomorrow, due to some reasons, if the data distribution totally changed, like one side it's skewed totally, then the model still assumes it's a like a perfect bell curve, but then data distribution got changed, right? So it might give some answers which does not which are not going to be relevant at that point of time. So that is like one problem. Also, so we call it like data drift, right? So data is drifting, and then there's a concept drift also. So the concept drift is like we train the model, data distribution is not shifting, but the relationship is shifting. So that means when I train the model and my model is based on some feature, and I assume like there is a strong correlation between those features, so that skewed my prediction. But tomorrow, if the relationship changed, the correlation changed, it might give me something which is not relevant anymore. So that is also called concept drift. So similar way, that could be both, right? So we also tell customers, like, you need to make sure the model once in production, it's not done deal. You need to make sure you are proactively monitoring the performance, proactively monitoring the correctness, so that it stays relevant. And if not, then we need to take an action. And most of the time we have from Azure MLOps offering, we have a solid offering for monitoring. And actually, with monitoring, we can auto detect those and send signals so that ops guys can take care of when that anomaly or any problem happens on those areas. So these are the some challenges I have seen, and we ask customers to follow this rigorously.
Wow, wonderful, Bani. But let's talk about practical implementations. So, talk to our viewers about some of the common mistakes that you see teams making as they're trying to operationalize ML on Azure, and how are you helping them rectify those mistakes?
So like if I see, sorry, I'm just trying to understand the question from a different perspective. Is the question like, if I am seeing someone is making mistake, how would I recommend rectifying it, or how would I rectify it?
A mix of both. How would you recommend rectifying it?
Yeah, so as I said, like if we are diligently implementing these MLOps practices, and we are following the framework, and we are following the guidelines, then it is much more easier, right? So I was giving examples of data drift and concept drift. Those are the main things where the machine learning model prediction can go wrong. So we have this offering where we can actually monitor from Azure whether the data drift is happening or whether the concept drift is happening, right? And then the monitoring can be actually part of that pipeline step also, saying like, hey, monitor. And it is continuously monitor. And as part of the monitoring, it can be said like, you monitor it every day at 12 p.m. Make sure everything looks good. Or you can set it like a pre-schedule, like every 1 hour you monitor depending on the traffic pattern and everything, right? And we can go one step further. We can say like, if there is a threshold, I can put a threshold saying like, if my error threshold is 10%, if it is more than 10%, actually run another sub pipeline which will take that model and understand what is the problem. Is it a concept drift or it is a data drift? If it is a data drift, it will go and fetch the new data and try to understand like whether it has the change in the distribution, and rerun that training script or like the training step, and make sure the model is rectified, making sure the model works well now, because it has the evaluation also as part of the model training. And once that models looks good, it can automatically deploy it. So this is like the whole end-to-end and fully automated process. I can fully automate it today. So based on that threshold, it will automatically do that. Now, but with automation also comes a lot of responsibilities, right? You need to make sure these are like the known issues. If there are some unknown issues or new issues or new reason, it's difficult to automate. So automation is like when I'm doing it repeated time, the similar pattern. So for new patterns, it's case to case basis, and we sometimes see issues there, saying like, okay, so data drift is working fine and concept drift is also working fine, but there could be some other issues with real performance, like probably the CPU utilization, because again, it's running on real hardware, right? CPU utilization or memory utilization, or even for inferencing, there is a scoring script. So the concept of scoring script is like, once I have the model, I host that model in a container, and in that container there's a little bit, I'll say, like the Python script, to make it very simple. And what that Python script does is like takes the request and does some pre-processing and send that request to the model, and then model send the output of the model is the response. So it takes the response and send it back to the user, right? So there could be some issues with that stage also, like there could be memory leak, there could be container issues also while it is running. So those are like case by case situation. On those situations, we look into the operational log and figure out what is going on. And Azure MLOps has, like, overall our Azure platform has a very good logging facilities also, so we can look into the logging and figure out what else is going on, and if we need to have like manual intervention. And in that case also, if we see repeated pattern, we can automate that also.
Wow, wonderful, Bunny. Bunny, let's talk a little bit about the impact of LLMs and generative AI on Azure MLOps practice. All right. Do you see any impact on that, or how do you see it?
So I can tell you like some of the customer stories here, which is definitely very encouraging. So we have, I'm again, like, I'm not taking like real customers' names. So obviously, like I'm just putting up some names here. So I know there's a huge retail shop, right? So they have like around 1,000 stores, and they have like relied on manual error-prone forecasting method. So forecasting is kind of one of the bread and butter for these retail stores, because they need to predict the product demand. And since it was manual initially, so and they also sell a lot of perishable goods, right? So it's if the prediction goes wrong or the forecasting goes wrong, then it's resulted in storage cost or the potential waste. And also understocking led to loss of sales and decreased customer satisfaction, right? So it's a very sweet spot. And also in terms of scalability, like, since it is a manual process, some data engineers or some folks who are doing it manually over a few Excel, it could be humongous depending on the input data set, right? So what we offered is like our Azure MLOps pipeline. So we kind of enable them with like super orchestrated and well organized pipeline, where it can take like historical data, trying to find out the pattern and what algorithm is suited for demand forecasting. So with that, I think the retail actually was very successful. So there, I know, like, even with the manual forecasting, it can be very accurate, because again, you have a lot of quality, a lot of people are actually doing it. But when we automated it, the best benefit we are getting out of it is like we can iterate faster, right? So manual iteration takes time, because it's a longer haul process. But when we automate it, we can iterate, and we can even set a threshold saying like, if we are not meeting accuracy like 90%, will keep retraining, right? So quick iteration, that helps. So the forecasting accuracy improved by about 35%, leading to better resource allocation and inventory management. Then efficiency of speed, right? So the training and deployment times decreased by 75% due to parallelize. Like now we have pipelines which are running, and we can make those pipelines running in parallel, also in parallel compute, especially on a region specific demand forecasting, right? So say for example during space allocation, it's only applicable for North America but not for Asia, right? So there can be demand forecasting running for the geography specific model, so that way increase like 75% like efficiency and speed. And again, like scalability, since I think since now we are on Azure, and with Azure Infra for MLOps inferencing, we have this elastic capacity, right? So depending on how much requests per second, we can actually put more muscle into the computing power. So that way, like it's like we could make like 50,000 predictions per second, which was like huge. So with this kind of optimization, it was a huge success for the customer.
Wow. So let's talk about collaboration, Vani. So obviously this requires collaboration, as you also pointed out. There are DevOps engineers, there are business of people, and there are other people involved in the process, right? So how does the platform, the Azure MLOps platform, how does it foster this kind of collaboration? And any soft skills that you think are very important?
Soft skills are always important for sure. So the thing is that, as I said, like there are multiple roles and different people with different capacities. They are working on different parts of the puzzle. So we can consider this is like a puzzle. So everybody is focused on their own localized part. But until and unless I'm seeing the whole end-to-end scenario, it's very difficult to put those together, right? So in Azure ML, we have this concept of workspace. That's the whole point of having the workspace. It's like one place where I have all the folks, or like all the different people collaborating. So to foster the collaboration, we encourage like, hey, this is the work area, this is workspace, you put everything here so that everyone who has access to the workspace, that means who is part of the team, they see what is going on across, right? So in the workspace I have the data. So data is like an asset. So one I as a data engineer, I bring my data, so that and once I'm happy with the cleaning and ETL, I register that data set. So that means if I'm part of the workspace, I see like, okay, so I have this data already for me to consume. And since, as I said, like those are version, right? So that means I have V1 of the data set ready. Even though V2 of the data set, maybe the data engineer is already working on it, but I don't care at that point of time, because I have something I can work on if I'm a data scientist. Because for a data scientist, data is the starting point. So once I see that data, then I figure out like, okay, so to get the model out of data, I need to come out with the script, or like what algorithm I should choose. So I let me focus on my part of the area, like the pipeline that I'm going to contribute to, right? So my output as a data scientist could be like the model. And once I get the model, that is also version, and put it as part of the workspace. And then once I get the model, then I can actually operationalize it. Then I give it to the ops folks. And what that ops folks are doing is like, they are preparing the pipeline, saying like, okay, data pipeline step is there, the model training pipeline set is there, and now I got to take this model and operationalize it. So now he's owning that pipeline, which is the whole Uber thing, which is doing the magic from here to production, right? So that is also part of the workspace, right? So that's the thing, right? So we are making sure all the different roles, all the different people who are working on, they are part of the workspace, and that fosters the collaboration, and people see what each one is working on. They can comment, they can share, they can collaboration. And definitely soft skill is a huge skill there. And for that, I mean, Microsoft has other tools also, like Teams. We can quickly sync up in Teams. Especially in COVID time, it was very difficult because everyone is working remote, right? So we can quickly sync up with Teams and share the workspace and have a consolidated understanding and go back to the workspace and do the work.
Yeah, that's wonderful. That's the workspace allows multiple people from across the organization so that they have the same view of everything that's going on. That's beautiful. Bani, let's take a look ahead and talk about the future stuff. So with Gen AI, MLOps, Agentic AI, they're all evolving. How do you see the role of MLOps and the supporting tools that Azure has been planning in the next couple of years? I know 3 to 5 years is a long time, but how do you see that evolving?
So when I wrote this book, I was actually thinking about writing the book about LLM ops or even agent ops, but I thought that might be little bit difficult coming from DevOps, right? Because it's a lot of step jump. So that's why I thought like like ML ops would be a good starting point, because it is a middle point where people from DevOps or like like ops engineer, they can come into MLOps and understand the basic concepts. Now, when we go to LLM ops, it actually changes quite a bit, because now most of the things we are not doing in LLM ops, because the main meat of ML ops was producing the model, right? And once we get the model, we deploy it. But here in LLM ops, the model is already there. So that means the data collection and data cleaning and choosing the right algorithm to make the model, and then deploying that. Deployment is still there. I'll come back to that. But until the production of the model, that part is totally gone, because now we got the LLM. But some of the challenges, there is a little bit of overlap, and that's where the ops part comes into the picture. And the huge part of that will be like monitoring and understanding how my LLM is actually behaving in production, real use cases, right? And LLM ops has its own challenges. The major ones are like the hallucination, right? Like it I don't know which data set it has been trained on, but if I ask it a simple question, sometimes it might give me some answer which is not expected, right? And also, like uh, if one LLM model is actually giving some answer, sometimes I need to understand why it is giving that answer, right? Interpretability or traceability, why it is giving that. Because if I know why, I probably have some clue and I can probably fix it. And that's why the thought process is there and thinking models are there. And also, the other major part is like responsible AI, right? So are we, how much reliant we are on the output of the LLM? Like, is the content coming out of it is very explicit? Can it harm someone, or like can it harm some people? So that's why we got a like raw power, I'll think, like LLM, but we don't know how to control it, because if it is uncontrolled, it's like it can do a damage. So it's like a controlled fire where I can cook my food versus uncontrolled fire where I can burn my house, right? So that's why a lot of guardrails, a lot of monitoring, a lot of understanding. Like, okay, we got the model. Now what to do? So there is a lot of focus on operationalization, making sure it is effective and it is not harmful and it is doing its right thing. So monitoring has to be solid, and the detection if there is any such issues. So that's why, like, if we have several detection technologies, like if it is harmful, if it is sexual in content, or if it is like suicidal, some filters, right? So with those we can monitor, and we can those are part of our Azure LLM Ops offering. So I think coming back from DevOps and MLOps to LLM Ops, I think the part which carries forward is still like the monitoring and detecting and alerting. So that's the key part we are still carrying forward, and that is very useful in this new world.
Hmm, interesting. And Bani, are there any specific tools or features within the ML Azure Ops stack that you feel that people or developers are not really aware of? Something that you want to highlight?
So I mentioned like the monitoring part. So as part of AML MLOps, we don't have natively monitoring support. We didn't do it, I guess, because Azure has a good monitoring support, right? Because Azure is more general purpose. It is not ML purpose, right? So the way we position is like with the ML part, it will still give me the logs, it will still give me the data, but now I can take that data and I can use my own alerting and monitoring system. So I can use Azure. Azure does great monitoring and alerting. Even Azure uses, like, we have this alerting which uses machine learning on as part of that alert management, where it sees like how long that alert has been open and what is the history of this alert, so that it can sometimes give like the recommendations how to fix it. Also, the other part of alerting is like dashboarding, right? So sometimes I want to understand how the things are moving, like if my model has been deployed, if how what is the quality of the model, is it failing sometimes, 95% of the time it is successful, by 5% time it is failing, and what is the error message, is there any correlation between the error message between what has been sent and what is the error? So sometimes trained on dashboard and trained on error and trained on other things. For that, Azure again has a solution, but sometimes we ask people if they want like fancy thing, they can use like other third party solutions, right? Like which are good in dashboarding. And I think we have these different dashboarding examples like Grafana, right? Grafana is one huge dashboarding tool. But what it does is like from Azure side or from Azure ML side, what we do is like at that point of time, we expose the logs and the raw data. And it's up to the customer or up to the user how they are going to use that data and put it into the dashboard. They can have their own third party dashboard solution.
Right, right. So, Mani, this is wonderful. Let's talk, talk more about your insights as an author now, right? So, were some of the difficult concepts or chapters that you particularly had a very hard time trying to explain?
Yeah, so I think it's like a little bit of looking back, right? As I mentioned at one of the earlier to one of the earlier questions, also like coming from coming from MLOps into the LLM. So it's little bit of a jump. So if we think of it like a evolution, so it's not a linear evolution. So MLOps to LLMOps is like few steps we jumped in between, because we don't need a model at this point of time, right? So the challenge with LLM ops again is like it feels like we are always catching up, because this area is evolving so fast. I mean, every night I go to sleep and every morning I wake up, I see something new, right? So it's a breakneck speed. It's very difficult to catch up with like that speed and get accustomed to it. But again, like with speed also comes responsibilities, right? So we need to think again rationally, like, okay, things are moving and there's a lot of churn happening and all these things, but what are the basic tenants that I need to put my focus on? And if I look into that again, it comes to those basic thing, right? Like responsible AI, being responsible, making sure it's not hallucinating, making sure if I am actually using that model to help someone, I am also responsible for which I am doing, because I cannot take my responsibility off, saying like I put the model and user is using it, is all up to you. But then I have the responsibility also. But that these are like more like ethical point of view from this. Now, coming back into the technical side, this is also evolving faster, because initially it came with prompt, right? So LLM and a prompt. So we can do a lot of prompting and making sure we are getting the meaningful output of it. Then it came with the prompt engineering. Okay, so now how to do nice prompting and how to version it, make sure the prompt stays with it, and it gives me consistent output of that. Then we were not happy, right? We need to LLM, whatever LLM has been trained on, it could be old data already. So then we came up with the RAG pattern. That means I can put my document and LLM will while answering, it will consider those documents or private database also to ground its response, right? So then the RAG pattern came. I mean, it came and it stays also because it is still a good pattern where I need to ground my data on some private database. But now beyond prompt, right? So prompt is okay. Now we are getting into the agentic AI. So it's beyond automation, right? So in agentic AI, I am not even in the controls. Like the LLM is controlling what to do next based on what is happening, what is the current state, right? So then we are talking about context. So prompt is there, but the context is more important. And now we are talking about the context engineering. So yeah, I mean, definitely these are challenging in a way, like these are not staying, it's jumping into the next concept as we are evolving. So it's a fast evolution and we are still learning. But I am hoping like at some point of time we'll have like solid parameters or like solid patterns that we can what would I say, like make generalization out of it and show like these are the patterns we should follow to make it successful. But we are still waiting for that to come up with.
No, I love, Bunny, how you spoke right from the MLOps to LLMs to AI agents, context, prompt engineering, then context engineering. So all of that nicely fits in, and you are right. Every day something new comes up and become extremely hard for us to catch up. But Bunny, if I am a professional today or a student today, and I want to learn more about MLOps, other than reading your book, what are the other things that I should be doing?
So there are different stages people are. So if they are totally new, I'm assuming like this question starts with someone who is already dev ops, right? Like at least they have some ops and development background. So assuming they know one of the cloud already, like either Azure, AWS, or GCP, right? So they know the basic concepts. Now, if they're coming to MLOps, so definitely they need to know the delta, the concepts, assuming they already know MLOps. So they need to know how DevOps fits into MLOps and what are the extra concepts that I need to learn. So either they can watch YouTube videos on relevant things, or they can read like documentations, or they can sometimes use like, in fact, chat gpt kind of LLM models also, saying like, hey, how does this work? So this is like more like a discovery. If you want to do a like you are learning something, but in between you found some gap and you are trying to cover that gap, so those things are really good for that. But I would not recommend YouTube for learning the whole end-to-end thing, right? Because you need a proper course where it goes through step one all the way to step n. So for that, again, like building on the concepts, reading documents, or at least start with some books which talks about these topics, definitely helpful. But again, like this is a technical thing, an engineering thing, right? So only reading will not help because this is not a theoretical, this needs to be practiced also. So if you like Azure, I'll say like start with Azure CLI. If you're a little bit more passionate, there is SDK also, which is one level higher than CLI, where you can write Python code. But again, it depends on the comfort level, right? But take any of the platform and check their CLI or like SDK they are offering and start doing it hands-on. And because if I don't do it hands-on, it's very difficult. I'll not learn. Only reading will not. So that will be my recommendation. Like start understanding, start reading, and then doing hands-on also to complete the cycle.
Yeah, wonderful, Bunny. So for my viewers, get your hands dirty. There is no shortcut to learning. And of course, I'm glad you mentioned tools like ChatGPT or Gemini, Perplexity. Those are extremely helpful whenever you see that there is a gap. And of course, there are books. But more importantly, read Bunny's book on this topic, which will be very helpful. So, Bunny, with that, we come to the end of the show. Thank you so much for taking the time to talk to our viewers.
Yeah, thank you, Arun. Thanks for having me. It was nice chatting with you.
Likewise, take care.
Thank you. Bye.